The judge is nice. Beg for forgiveness.
College student.
Come
I'm
on,
already eating ramen noodles. I had to ration out a whole pack of ramen noodles for 1 week.
Do you have any homework questions as you got ready for this quiz today? 2631 or 32?
I didn't get through all of 3 2.
53. 53 on 178?
Yeah.
Says main reservoirs recently found to be contaminated. A proposal submitted to the city indicates that the cost of removing X% of the toxic pollutant is given by this formula: 0.5x over 106. Okay. They want me to find the derivative and find the derivative at 80, 90, 95, and 99% to see how much it would cost. Or at least, what would the rate of change of cost be? Okay. Let's do it. So if we find C prime, I'll have to use the what? Yes. Quotient rule. Denominator times derivative of numerator minus numerator times what? Negative 1 over 100 minus x squared. That's going to be 50 minus 0.5x plus 0.5x. Is that right?
Yes. When you take the derivative of the numerator, wouldn't it be 1 plus or 1 times 0.5?
Which is just 0.5, right?
Well, in my head, yes, but in the calculator, no. That explains why I messed up.
Okay. 100 minus x squared. That means those subtract out, and you get 50 over 100 minus x squared. Okay. If we find C prime of 80, that's 50 over 20 squared. Is that 50 over 400? Which is 1/8, right? Which is, now when we get an answer here, is it in millions? In millions of dollars. So 1/8 of a million would be,
125,000.
say that again?
125,000.
So that would be the rate of change of cost if they want to remove 80%. It would be $125,000 per percent. Because that's changing Y over changing X, and X was percent, right? Wow. Okay. So if they want to remove 80%, the next percent would be $125,000 more to remove. Ouch. If we put in, did they say 90 next?
Mm-hmm.
Well, that's not too bad. That's just 1/2, isn't it? Oh, but that is bad because that's going to be $500,000, right? So you see what's going on there. The closer you get to 100%, the more expensive it is for the next percent to be removed, right? And I could never put in 100 because I would get an undefined expression. But if I put in 99, that's going to be $50 million.
Here's Flint's answer.
What's that?
Here's Flint's answer.
There you go. That's why they're drinking lead, right? That's how it started. Is that good?
Yeah.
And it was just your little-
I plugged it in. And I did it twice.
Just remember, if you ever have just x to the first power, that's just the coefficient. The derivative is just the coefficient. So if it's like 8x, the derivative is 8.
Right.
So that's good. Any others?
Number 55, same page.
55. You know what? Come on. There we go. It's not being very nice.
Yeah.
Let's see. There we go. 55 says, number of bacteria N of T in a certain culture T minutes after the experimental bactericide is introduced is given by N of T equals 10,000 over 1 plus T squared plus 2,000. Find the rate of change of the number of bacteria 1 minute and 2 minutes after it's introduced. What is the population of bacteria in the culture 1 minute and 2 minutes after it's introduced? Okay. The second part of it, I think, is just plugging 1 and 2 into the original function. But the first part says find the derivative and plug in 1 and 2. So if I find n prime of t, you agree with me that the derivative of this is 0. So I'm just going to find the derivative of this by the quotient rule. So that'll be denominator times derivative of numerator minus the numerator times derivative of denominator over denominator squared. Negative 20,000 t. Whoops. That's yeah. Over 1 plus t squared squared. N prime of 1, the rate of change after 1 minute, that was the unit, right?
Yeah.
Okay. N prime of 1 would be negative 20,000 over 4. Is that right? 2 squared 4, so negative 5,000 bacteria per minute. So that would be the rate of change at the first minute. It would be decreasing by 5,000. That makes sense, doesn't it? After 1 minute, if you introduce something that's going to kill them, that's a pretty big number, right? But if you put in 2, that'll be, 2 would be negative 40,000. Oops. Over 25.
Mm-hmm.
That is
16,000.
So
1,600. Negative 1,600.
that makes sense to me because when you first introduced it, it's going to kill a lot, and after 2 minutes, maybe not as many. So you see how that rate of change is decreasing? It's not killing as many per minute. They're still killing them, but only 1,600, which is like more than a third of what it was. So it's not killing as many after 2 minutes, and I guess that would continue as the time went on. So, and I think that last 2 questions, they just want you to plug 1 and 2 into the original to see what the population was after 1 minute and after 2. So, any other concerns about any of the rules that we've done up through 3.2?
Can you show how to do number 13
13.
on that? Mostly it's set up for neighbor.
Do you think the problem was with the simplifying to get the answer they got, or?
I think it was 55 there was at 2,000. That was like, where do you know, what do you do with that? How does it play into the formula? But since it is zeroed out,
Yes.
that makes it more
That's it.
sense.
You said 13, right?
Mhm.
13. Gives me f of x is x squared minus 5x plus 2. I'm going to write the second
What, this was on one, second one?
minus 2x to the negative 1. That might make it a little easier instead of 2 over x. If we use the product rule, that would be what? First times derivative of second, which would be 1 plus 2x to the negative 2 plus derivative of first times original second. The rest of that is just distributing and seeing if you can get what answer they get in the back. And like I said, if you show me that you know this, I know that you know the product rule. And I don't think on the quiz I give you one that would be that involved if you did simplify it. So try to simplify if you can, but this would take probably another 7 minutes to finish satisfactorily. But from there you would just distribute and see what happens. That would be a mess here, wouldn't it? And then this would, what's nice is like when you distribute this, the outer product would just be negative 4, wouldn't it?
Mhm.
Because the x's would cancel. That would be nice. But yeah, from there on, it's just trying to simplify and get their answer. But if you've got those 2 terms, you're on the right track. Okay? Any other concerns about those sections? Okay. If you haven't tried the chain rule problems yet, do those over the weekend and let me know. Next Wednesday, right? Is that right?
Mhm.
Wow. Okay. But before we take the quiz, if you don't have any other questions, I'm going to go ahead. 3-4 is an important section, but it's not a very long section for us. We're not doing all the applications in 3-4, but I would like to go over what I'm expecting from you on those. Let's see. Here is your definition. I could have sworn that computer would be on when I came in here, but it's just now warming up. It must be getting old. Okay. Let's see. Here is your definition. If it'll come up.
Gonna have to do a cost function for the new computer.
What's that? Oh yeah. I need to tell them that we probably need to switch it out because it shouldn't be doing this. And I bet they'll do that if I just ask them to.
Here.
But
It's coming.
coming?
It's a trouble.
As soon as I step over here, it will come up. Here's what we want to do in this section. Marginal analysis, study of rates of change in business and economics. Anytime I talk about marginal cost, capital MC, that just means the derivative of the cost function. That's the rate of change of cost. All right? Rate of change of total cost per unit change in production level X. And we saw a problem just a second ago with C prime, didn't we? All right? A good way to think about what it actually means, though, it's the cost of producing the X plus first unit. So if I said find C prime of 100, find the marginal cost for 100 units, that would be the cost of producing the next item, the 101st one. Okay? So that's a nice way to think about it. That's the instantaneous rate of change of cost. So at 100, the instantaneous rate of change would be the cost of producing the very next one. Okay? Same thing for revenue. Marginal, and please go up, yeah. Went up too far, didn't it? Marginal revenue, R prime of X, the rate at which the total revenue will change with unit change in production level X. Derivative of the revenue function. Revenue from selling the X plus first unit. So if I said find the marginal revenue at 50 units, when you found it, that would be the money they bring in from selling the 51st, the very next one after 50. Okay? Selling the next one after whatever X is, the X plus first unit. And the marginal profit follows right from that. Marginal profit, P prime of X, the rate at which the total profit changes with unit change in production level X. Profit from producing and selling the X plus first unit. So if I said what's the marginal profit for 1,000 units, it would be the profit from the 1,001st that's sold. And you all remember how to form the cost, revenue, and profit functions from our first quiz, right? Remember that we did last quiz? Okay. Same old thing, but now we're going to be finding the derivatives of each of them. And that's really this whole section. So let's look at a few. Number 4. I apologize for the length of some of these functions, but they're trying to be as accurate as possible. So they give me a cost function, and this is talking about microwave ovens. C of X, and this is page 205 by the way, 0.0002 X cubed minus 0.06 X squared plus 120X plus 5,000. Okay. X is the number of units produced, okay, and C of X is the cost in dollars. The questions are on the next page. What is the actual cost incurred of manufacturing the 101st, 201st, and 301st? This is what I would do. Would you agree with me for part A? The cost of the 101st oven, which would just be, if you said, what's the cost of making 101 and subtracting out what? The cost of making 100. Would that make sense? If you said, what's the cost to make 101 ovens, and then you subtracted the cost of 100, that would be just the cost of the 101st, wouldn't it? Well, I'm going to be real lazy and enter that into my calculator in line Y1 if the calculator will come up. And we'll use our table for that. If I enter, that was, this is obnoxious. Okay, it's blinking, so let's hope it wants to be nice. Control that. If you want to type that cost function into your calculator, there we go. Okay. Now it might let me enter. It was what, 0.0002 X to the third. Okay. Let's see if it let me. Over here. Minus 0.06 X squared plus 120X and plus 5,000. Here we go. If you go to your table, put in 101. Is that what you got? What if you put in 100? Do you agree with my numbers?
I've got something different.
Uh-oh. Let's look at my function.
I might have put more.
0.0002.
I did,
X.
I missed a zero.
If I subtract those, what do you say is the cost of the 101st? 114. Good. Okay. Then it also says do that for the 201st and 301st. So if I said 201 and then 200, that's going to be 120. Do you agree with that if I subtracted those? 120. And then 301 and 300. Good, 138. So, the reason they wanted you to do that is now if we find C prime, if we find the marginal cost, like we were talking about, let's see if it gives us the same thing. So for part B, we want to find C prime of x, which would be what? Point. Would you agree with that? What would the second term be? 2 times 0.06 would be, is that 0.12x plus 120, okay? What if we go back to our calculator and enter that, and we say y equals, that was 0.006 x squared, and what was the rest of it? So, minus 0.12? Oh, thank you. There we go. Minus 0.12x, and it was plus 120. Okay. If I go back to my table, and I'm going to delete everything I have there. If I put in 100, do you see that y2 gives me 114? So C prime of 100 was 114 without us having to find them and subtract. Remember how we did on part A? Same answer, right? What if I put in 200? What do we expect it to be from what we did in part A? Ah. And 300, we said it was 138, wasn't it? Cool. What do you think of that? Isn't that nifty? That I didn't have to do that whole long thing and subtract the two. If I want to find the cost of the 101st, 201st, 301st, I just find C prime of 100, C prime of 200, C prime of 300. And it gave me the 114, the 120, and the 138. Isn't that great? Instantaneous rate of change.
Because that's basically the difference.
That's basically, yeah, that's basically finding the instantaneous change in cost when you make 100 of them. That's the cost of the next one. So that's what we'll have. And they just wanted you to do that to see that, hey, they're the same. And isn't this easier? And it is, because think how long it took me to type that in, right? This was a shorter function, easier. And I didn't have to subtract them. Now, number 6, I want you to look at what they've added to that. They've added a word to it. Instead of just marginal cost, what does it say? Marginal average cost. So if you have a function c of x, if you put a bar above it, we call that the average cost function. Average cost. And c bar of x is equal to c of x divided by x. And that makes sense, doesn't it? If you take the cost function and divide by the number of units you produce, that's the average cost, isn't it? That averages. Okay? What they asked me to do in number 6 is take the function c of x, which is, I'm going to write it 2x plus 5,000 if you don't mind. Find the average cost function. So what will c bar be? 2x plus 5,000 over x, right? And I could write that 2 plus 5,000 over x if you wanted to. If I split it into two fractions, right? And then part B says find the marginal average cost. Find the derivative of that. Well, how should I write that to make it easy to find the derivative? Okay. And you know the derivative of that 2 would be 0, wouldn't it? So what's the derivative? What will be the marginal average cost? Good. And I could write that negative 5,000 over what? And that would probably be even better to use, wouldn't it? Okay. Let me make that a little straight here. Marginal average cost. And then it says, interpret your results. What's that going to tell me? That's going to tell me the instantaneous rate of change of average cost at level X, right? So if you said you made 100 units, right, that would be the rate of change of the average cost at 100 units, or for the next one, for the 101st, on average. Okay? How quickly it's increasing or decreasing. What do you notice about this, though? This is always going to be what? Yeah. So do you see that as X gets larger, doesn't the average cost go to 0? Like what if X gets larger and larger and larger in that? It's going down, but it's not going down very much, is it? As X would get larger and larger and larger. But it would always be decreasing. And that makes sense because the more units you make, the average cost should decrease. Like what if you made 100, it would cost you a good bit to make, but if you made 1,000, you probably would, it wouldn't cost you as much per unit, would it? The average cost would be smaller. That's what that would tell you. That's, I think, what they wanted you to notice, that since this would always be negative, because whatever you put in here is squared, it's always falling, but depending on how large X is.
So the marginal average cost is the same as the rate of change?
It's the rate of change of average cost rather than rate of change of just plain old cost.
Okay.
Right. So if they gave us the cost function was this, C prime would be the rate of change of cost for X units, right? Or the cost of that next one. This is the rate of change of the average cost at X, at the level of X units of fraction. So, that's good. 10 is on marginal revenue. Now this is where I wanted you to look closely at this question, because sometimes there's been a little confusion on how to form what we need here, but I think you'll see it just fine. Let's see. Number 10 says, this is for speaker systems. They determine the demand function. The P is equal to negative 0.04x plus 800. And that's for X between 0 and 20,000. P is the speaker's unit price, and X denotes the quantity demanded. Find the revenue function. Remember that revenue wasn't that selling price times number of items. Well, this is the selling price, and X is the number of items. So P times X, which would actually be negative 0.04x plus 800 times X. If I distribute it, I'll have a nice, easy function to use if I need to. So there's my revenue function. Selling price times number of units. Okay. Find the marginal revenue, R prime. What will R prime be? Negative 08x. Would you agree with that? Okay. And then they just say compute R prime of 5,000 and interpret it. Okay. What is 0.08 times 5,000? Okay.
Would be negative.
Negative 400 plus 800?
Yeah.
So is that 400? What does that tell me? How would you interpret that? That $400 is the revenue from what? The 5,000 and first revenue from the 5,000 and first speaker system sold? Okay. These are easy, aren't they? We know what cost, revenue, and profit are. Now we're just taking the derivatives of them and interpreting what that would mean. So this isn't bad at all, I hope. I think. One more, and I think we can take our quiz. 14 asks us for the whole deal. Cost, revenue, and profit. So, in 14, they tell me that this time we're talking about 20-inch flat tube digital televisions. Okay? They say the demand function this time is P is negative 0.006x plus 180. And the cost function is another ugly one. That is what, 5 zeros?
Yeah.
It's x cubed minus 0.02x squared plus 120x plus 60,000. Very good. Then they say answer the questions from exercise 13 above for this problem. Part A says find the revenue function and the profit function. What is R of x? Yeah, P times x. So we would say negative 006 x plus 180 times x. Just like in that last one, P times x. All right. You tell me if this starts to get too ugly and you see where it's going. I can stop writing at any time. But you see what revenue is. How would you form the profit? Yes. I'll say revenue minus cost. Would you like me to write this down minus this and subtract them? Could you all do that if you were forced to? I promise my cost functions on the test or quizzes will not be that long. You understand what you would do, right, there? R minus C, you would distribute your negative through there, you would combine, and you would have your profit function. What are they asking you to do in part B?
On the marginal cost function, C prime.
C prime, R prime, and if you did this, P prime. Could you all do that? Is there anybody that thinks, I want to see it? You see what I'm saying? You could also, we could find that easily. We could say 3 times this, that would be 506x squared minus 0.04x plus 120. Revenue even easier, but profit, I just didn't want to make you sit there and form that. That's mind numbing, right? But that's what you would do. C prime, R prime, P prime. Then they ask you to plug in some numbers. What would C prime of 2,000 be if I found the derivative? The cost of the 2,001st TV, 20-inch digital TV. Okay. R prime of 2000 would be the money you bring in from the 2001 TV sale. And P prime of 2000, the profit from the 2001. Very good. And that's all they ask you. They do say sketch the graphs. I probably would not ask you to sketch the graphs in here. I just need you to know what that means, right? What C prime, R prime, and P prime is. Okay? The ones I want you to try, though, why don't at home you try and make sure you can work these 3 through 17i. So from page 205, why don't you try 3 through 17i, and that's all we're going to do in that section. After this section, we skip over to 3.6. We save 3.5 for the next unit. So on next Wednesday, we will see if you have any questions from this or from chain rule, and then I will go on to 3.6. After 3.6, we do 2 sections from chapter 4, then we're ready for our next unit. Okay. Do you have any other questions on definition of derivative? Your power rule, your product rule and quotient rule? I might want to say one thing before the quiz. This one always bothers people. If I gave you f of x equals 5x to the negative 1, what is f prime of x? How would be a good way to write that answer?
Negative 5 plus.
What if on the quiz the last question says, where is that differentiable? Where is this function differentiable? What would that mean? If I ask you where this is differentiable, that just means where does this exist? What are the bad numbers and what are the good numbers? What's the only bad number for this? So you would say differentiable for all real numbers, but what? If you had a radical, you couldn't let a negative be under the radical, could you? So if I say, where is a function differentiable? Look at that and say, where is this function good? It's good everywhere except 0, everywhere except certain numbers. Okay? That always bothers people. But otherwise, this is very straightforward. Okay. So, you'll have plenty of time for this. No rush. Everything is 2 points